Hello there. In this episode we're going to be talking about branching. Prior to this, all of our programs have taken the form int main. By the way, you don't actually have to put that stuff in the brackets there. I forgot that you could do it like this. Really, you only need this stuff in the brackets if you're receiving input from outside of the program. So this is a quicker way to do it. So all of our programs have taken the form int main brackets, either with the standard args in there or not, an open brace, and then we have statement 1 semicolon, statement 2 semicolon, dot, statement n semicolon, close brace. So all of our programs have just been a sequence of statements, and these statements are executed in the order at which they appear. That isn't very useful. There's only so many types of program you can write with that, unless your statements happen to call functions which are very elaborate. But generally, there's not a lot you can do. What we need to be able to do is make decisions. We need to be able to make statements and then make decisions. And if you think about any process that you would follow in real life, even cooking a baked potato, you can't just do it as a sequence of linear statements, like put it in the oven, statement 1, turn the oven on, statement 2. You know, when do you take it out? You'd have to have a statement, wait 45 minutes. How do you know when 45 minutes are up? You need decisions. You need to say, start a timer, observe the timer. When the timer hits this certain level value, stop the oven. You always need decisions, and that's what branching is, or conditional execution. It's called branching because we're going to split the program into different directions effectively. So let's look at a very simple example of that. So the most basic example I can give is what's called an if statement in C. First of all though, I'm going to define an integer x and give it the value 1. And if you remember from the episode on types, 1 is equivalent to meaning true in terms of logic. Where that logic comes in is in things like if statements. So we can now write if x. So we have the if keyword, an open bracket, curly bracket. Then we have the thing which we want to evaluate, and then a close bracket. Then we put a brace, and then we can put statements here. So maybe we just print x is true. And then we close the brace, and we can put as many statements as we want in between the braces. So what this will do is, x will be evaluated as a logical variable, if you like. So because we've set it to 1, this means that x will be evaluated as being true. And whatever you put in the brackets here has to evaluate either true or false. And what happens is, we say if true, so if x is true essentially, if true, then execute whatever's in this first part of the braces, between these two braces. So this is going to see that x is 1 and it's going to print x is true. What we can do though is add another half to the branch. We can say else, so, and put another brace, and we could write printf x is not true. So then, in this case x is 1, so x is going to be true, so all this is going to do is print x is true. Whereas if we set this to 0, so that's going to evaluate to false now. And what will happen is it says if x is true, it's not true, so it doesn't execute that, else, so otherwise, do this, and it'll print x is not true. So that's the most basic form of branching that you can do. Let's take a quick look at that. So I've got the usual setup, a new program here on the left called branch.c, and in the make file I've got default and branch. So when I type make, it's going to compile the program. So let's write what we just did on the board. So if x, and you could say if x equals 1 if you wanted, but say if x, printf, x is true. And we're just going to leave it like that. Compile that and run it. And as you see, x is true. If I change this to a 0, recompile it and run it again, nothing's printed out because x was now false. If I set this back to 1, and now I add in the other half of the branch, x is not true. Now compile that and run it. Still got x is true because we set x to 1. Now this time if we set x to 0, just compile that then and run it. Now because x is 0 and we had the other half of the branch, so x was not true, so then it executed this other half and it printed x is not true. So that's branching in its simplest form. That is the if statement in branching. Just to show you the other type that you can use, which is the bool type, if we include standard bool.h, we can actually define x as a boolean and actually write true. So then this kind of makes it might make more sense to you to say x is true like this. Just compile that and run it. So you can do it either way. So bool is the new type, and perhaps that makes it more readable. You can see it's a boolean variable. It can only have the values true and false, whereas before we were using an integer. I don't know. You'll see so many programs that don't use the bool type. They use integers for the bool type, essentially. So it's probably worth starting with the int type, I would say, in C, because you're going to see that so often if you try and look at anyone else's code. And then perhaps if you if you write a new program, perhaps use the bool type so that people in the future can have a slightly easier time. So the way that in general an if statement works is as follows. If the statement there evaluates to true, then branch A is executed, and branch A will be a series of more statements. Otherwise, branch B will be executed. So when statement is true, branch A is executed. When statement is false, branch B is executed. And that kind of follows semantically kind of how it sounds. If statement, then do this. Else, do this. Now, statement has to evaluate to either true or false, but it doesn't have to be a single variable. It can be a compound of variables. So in our statement, within an if clause, we can use what's called logical operators to combine a number of variables. So to give some examples then, if we defined a variable called raining to determine whether it was raining or not, and a variable called has_u to store whether or not I have an umbrella, the U standing for umbrella, I could then make the statement, if it is raining and I have the umbrella, then do something. And that would be written like this. if raining, and then and is a double ampersand in C. So that's not good. So and has underscore U, then execute the branch. So that is called and it's a conjunction, and it follows the natural language understanding about what and means. It's probably worth briefly looking at and from the perspective of what's called truth tables, because for each logical operation, the logical operation will behave on the operands and produce an output in a predefined way. For and, it pretty much follows, well, it does follow exactly how you'd expect and to work. It works as it does in real life. So this whole statement is only true if both of these variables evaluate true. So if it's both raining and has, and we have the umbrella. Just to kind of formalize that, what we can do is write what's called a truth table. And we can write our variables down. So raining, if these are operators, and we could substitute this for any name, and the and operator is going to behave the same. Has umbrella, and then write two ampersands. And what we can do is then characterize the behavior of the AND operator based on the values that these two variables have. And these could be anything, they could be A and B. So these stand for any two variables. Now, it's either raining or it's not. And we either have the umbrella or we don't. So there's two possible combinations for each of the variables, which then gives four possible combinations, which are as follows. If it's not raining, and we do not have an umbrella, then both of these are false. So neither of them are true. So false and false is false. Because and means that they're both true, right? The next one is if it's not raining, but we have our umbrella. Well, they're not both true. So again, the and operator applied to them evaluates to false. The next one, it's raining, but we don't have the umbrella. Again, they're not both true, so it's false. But in the final case, if it's raining and we have the umbrella, then they are both true, therefore the and operator evaluates to true. And that is called the truth table for the and operator. And it behaves kind of as you expect. Another common operator is not, so to invert a statement. So I can say if it's raining, but perhaps I also want to say if it's not raining, and I don't want to have a separate variable for that. So if we again had our variable raining equals 1, let's say it's raining, what we can do is write if not raining. Which means that this will be, the statement will evaluate to true when raining is false, so when it's not raining. So not, and that's an exclamation mark, again follows what you'd imagine in real life. And to have a look at the truth table for that, so we only have one operator here called A, or raining in our case, but let's just substitute A now, because this could be any variable, and the operator not. So if A is false, then not false is true, so when you apply not to it, it becomes true. And if A is true, then not true is false. So it just inverts it. And that's the truth table for not. The other operator we're going to look at is called or. And where you would use or is in a situation such as the following. So imagine we again have our raining and our has umbrella variables, and somehow we assign the correct values to them. Then what we could say is, if it's not raining, or, and that's a statement for or, it's two pipes next to each other, or we have the umbrella, then we go out. Because if it's not raining, then we really don't care about the rest of the statement, and we'll just go out if it's not raining. But if it is raining, then we want to know if we've got the umbrella. And the or operator associates from left to right like that and is what's called lazy. Because in an or statement, if either of the statements applied to the operator are true, then the whole compound statement will evaluate to true. But it evaluates this from left to right, and it does so lazily. It doesn't need, if this already evaluates to true, then it doesn't need to evaluate the other side, because it already knows the whole compound statement is true. So that's why we can put it like this. If it's not raining, okay, imagine if it wasn't raining, then the whole statement's true, so we go out. Otherwise, it must be raining actually, because that would have evaluated as false. So then we check, do we have the umbrella? If we have the umbrella, if it has umbrella is true, the whole statement's true and we go out. If we don't have the umbrella, then that's false and the whole statement will be false and we wouldn't go out. So let's look at the truth table for or. And given our operands A and B, and or is two pipes. And so if A is 0 and B is 0, if they're both false, well, neither of them is true, so the output's false. If A is false and B is true, well, or operates as semantically you'd expect, well, one of them's true now, so the output is true, because it's either, or. If A is true and B is false, then the output is true because one of them's true. And if they're both true, then one of them is true, so the output is true. So that's the truth table for or. And in the body of an if statement, or in the evaluated part of the if statement inside the braces, inside the brackets, we can have as many combinations of and or as we want. And we can say, so if we could say if A and B and C, then, and that would only evaluate as true if A and B and C were all true. Because the operator and is what's called associative, which means that essentially A and B and C is the same as evaluating this first and then evaluating the result of that with that, and it's also the same as evaluating this part first and evaluating that with that. But anyway, we don't need to really go that deep. All I wanted to illustrate here is that you can combine variables together with logical operators that we're familiar with in real life: inversion, not, and, conjunction, and or, disjunction. So I've got the usual setup, and on the left here is a file called raining.c, and in the make file on the right I've got one default that says raining, so I can type make and compile it. So following the example on the board, if we had a variable called raining, and we set that to 1, and we have our has umbrella variable and set that to 1, then we could write a compound statement, a conjunction of those two variables in an if statement like this. If raining and has umbrella, printf, go out. Else, printf, stay in. Now let's see what happens when we change these variables. So if I set them first both to 0 and run it, we stay in because none of them was true. Imagine it's just raining and we don't have the umbrella. Then we stay in. Imagine we just have the umbrella but it's not raining. We stay in, which is semantically doesn't make a lot of sense. If it wasn't raining, then we would probably go out. But that's what conjunction means. They both have to be true. So if it's raining and we have the umbrella, then we go out. So just to be very clear there, that illustrates actually that semantically it doesn't matter what these statements actually mean. What matters is that they're both true. If we wanted to convey the idea that we want to go out if it's not raining anyway, regardless of whether we have an umbrella, we could do something like this. So we could say, if it's not raining, go out. Else, so we now know it's raining, if we have umbrella, go out. Else, stay in. Now, if it's not raining and we don't have the umbrella, and I run that, we go out. If it's not raining and we have the umbrella, we still go out. If it is raining and we don't have the umbrella, stay in. If it's raining and we have the umbrella, then we go out, which is perhaps what we would actually want to do semantically. Now this isn't the most efficient way to do this. We've got quite a few statements here. We've got the first one, if it's not raining, go out. And then we're kind of repeating ourselves here by saying, if we have the umbrella, then we go out, otherwise we stay in. It's actually a lot more efficient to do this as an or statement because we do it in a single line. So what we can write is, if it's not raining or we have the umbrella, then we go out, otherwise we stay in. And see, now we're just writing that on one line because we don't really care about the umbrella unless it's raining. So now let's have a look again. So if it's not raining and there's no umbrella, then we go out. Fair enough. If it's not raining and there is an umbrella, we go out. If it's raining and we don't have the umbrella, then we stay in. Because raining has a value 1, which is true, but not true is false. So this is false. So the whole statement will evaluate to a false and we'll stay in. But now if it's raining and we have the umbrella, we go out, which is what we expect. So it's raining. So this evaluates to false because we're talking about the inverse of that, not raining. So that side of the or is false, so we need to check the other side. But we have the umbrella, so that side of the or is true, so we go out. The whole statement evaluates to true and we go out. Right, so you now know how to write basic if statements, and you can write compound statements that evaluate to true or false and determine which branch of the if will be executed. Another thing you can do, you can nest these statements. So you can put if statements within if statements as many times as you want. So if we had our raining, whatever the value is, and has umbrella, then what we can do is we could say this: if it's raining and then within this branch say if we have the umbrella, then we go out. So we're not going to even get to here if it's not raining. We're just going to go straight to here, this next line after the if statement. But if it is raining, then we're inside here, and it's perfectly legal to then have another if statement saying, if we've got the umbrella, go out. And you can nest statements as much as you want. So you've seen the use of logical variables along with logical operators in an if statement in order to execute an if statement whether or not something's true or false. Now the statement in the if brackets can be anything that evaluates to true or false, and that's not just logical variables. A very important case which evaluates to true or false is a comparison. So if we want to check two things are equal and then perform an operation, what we can do is either call a function that compares the two things and gives us a true value if they're equal, and gives us a false value if they're not equal, or for the primitive types we can use the following operator, which is equal. There's two equal signs, so this means equivalence. And the way that that will work then is perhaps somebody needs to get their vaccine at age 3. Now what we could say is if age equals 3, then vaccinate. So the two equals allow us to compare primitive types. So that's integers, longs, doubles and so on. We can compare numerical types. There are several other operators which can be used to compare numerical types, and they align with what we use in everyday life. So one of them is greater than. Perhaps you can only ride a ride if your height is bigger than something. Let's just call it h. We could say if your height is greater than 5, that's a bit of a bizarre height, foot maybe, then you can go on the ride. Otherwise you can't. But if you think about it, if in that particular case that might be a bit weird if it's greater than 5. So if you're 5 foot you can't go on the ride, only if it's 5.1. 5.001. There's another operator though that allows you to say if it's greater than or equal to, because that perhaps often makes more sense, and that is greater than, so that sign followed by an equals. Go on the ride. So now if the height is greater than or equal to 5, we can go on the ride. The next operator, numerical operator, is less than. And let's use age again to give an example. Perhaps you only get in for free to the London Eye if you're below 3. Like children often get into free to things, don't they? So if age is less than 4, we'll say, then you can go on the London Eye. I don't know if that's true, by the way. Don't turn up at the London Eye and expect your kids to get them for free. I don't know if that's actually true. But that's how you'd express that in a program. And like the greater than or equal, you can have less than or equal. So So if the age is less than or equal to 4, you can go on the London Eye. Of course, semantically that doesn't make a lot of sense, because how could you be exactly equal to 4? It would have to be your birthday or something. Whereas if you were a day over 4, then you're not allowed on the London Eye. Something like that. But you get the point. So that's the numerical operators. You can check for equivalence. You can check for equivalence with equals equals. You can check if one thing is greater than the other with that symbol. You can check whether it's greater or equal. You can check whether it's less than, one thing is less than the other, or less than or equal. We're not restricted to just comparing a variable like age with an actual number, like we just showed. We can compare two variables as well. So we could have the age of the child, and we could have the maximum age that we're allowed to be 4, and then we could say if the age is less than or equal to, is less than or equal to the max age, then we can go on the London Eye. So we can compare variables together. I think that's really everything you need to know about conditional statements for now. This should now allow you to do quite a lot of things that involve conditional execution. As a final part of this video, let's try and make all that we've just seen a little less abstract. What we're going to do is create a program called quiz. So again, on the left we've got our quiz.c, and I've put quiz as the default in the make file. Now we're going to use a function called getC. So if you do man getC, this gets a character from an input stream. So you don't really have to worry about this at this stage, but all you need to know is that we can do this. So we're going to find a char type called C, and we're going to have getC, and we're going to read from a special file called standard in, which is actually the input stream on the terminal. And let me just illustrate this. So what this program is going to do is it's going to get a character from the standard input stream, so from the terminal, and then it's just going to print it out. So let me compile that and run it. And if you see, the program's doing nothing because it's waiting for that character. If I put the character A in, it prints got A. I can put whatever we want in there and it's going to print that out. So that function getC just gets a character from the input stream. So imagine we had a little quiz. We might want to print what is the capital of the UK? And then I'll tell you what we'll do. We're just going to declare our character up here first, then we're going to get our character. Now we're going to have an if statement to check the answer. Oh, sorry, we need to first print out the the options. So let's say we're going to have a tab and then have A, London, B, Paris, C, New York. No, it's not those, it's Washington. Capital of America, Washington DC. Then we're going to get the character. Now we're going to check the answer. And we're going to say if the character is equal to A, then we print F correct answer. Otherwise, we're going to print our printf. Sorry, wrong answer. So let's make that. Now we get asked, what's the capital of the UK? I'm going to try B. Oh, sorry, wrong answer. What's the capital of the UK? C. Sorry, wrong answer. It's London. Correct answer. So there we go. We're using the equals the equivalence operator to compare the character that we've read from the input with the character A. Now, what we're going to do is ask another couple of questions. So let's just copy this block, and we're going to have, what is the capital of France? So we're actually just going to cheat here and have all three of these. It is Washington, isn't it? I think it's Washington. And what we're going to do is we're going to have another variable which keeps track of the correct answer count. I'm going to set it initially to 0. Then we're going to say, so after our first question, if C equals A, which is the correct answer, then we're going to say correct answer count, and we're going to use this plus plus. So what we could do is write correct answer count equals correct answer count plus 1. But that's kind of a bit of a mouthful to say. Another way we can do that is writing plus equals 1, and that will add 1 to this variable. But there's an even more succinct way, which is just to say plus plus. And if you're wondering, that's where C++ comes from. It's the C language incremented. So that's called incrementing a variable. So we're adding 1 to correct answer count, if it's correct. And after our second question, the B is the answer. So we'll increment our correct answer count if they get it right. And after our third question, C is the correct answer. Just let me get rid of this. And again, we'll increment our correct answer count if they get it right again. After we've done that, we'll now use some kind of numerical comparisons. We'll say if correct answer count equals 3, then we'll print out congratulations, you got them all right. You got them all. I don't want to go into a new new line. Well, I'm going to have to by the looks of it. Cool, you got them all. Else, if correct answer count is greater than 2, sorry, greater than 1, and let's say if it equals 2. If it equals 2, then we'll write, okay, not bad. No, that's right. 2 out of 3 ain't bad. And else if correct answer count equals 1, 1 out of 3 needs improving. Otherwise, then we're going to print terrible 0 out of 3. So let's just give that a go then. So we'll compile that. Oh, and I've got some errors. Good. What's the first one? Use of undeclared identifier. Oh, that's true. I've written it as current. So let me just correct that. That should be it now. Type make again. There we go. It's compiled without error. Run the quiz. So what's the capital of the UK? Let's just try and get everything right. What's the capital of France? What's going on there? I'll just leave this in because I'm just going to control C that. It seems to have printed out both in a row. So why has it done that? So the reason it's done that is because this gets a single character. And when we press enter, it gets another character. I think I'm just leaving these errors in because I think it's interesting when things like this happen, just to see, you know, where you've made a mistake in your thinking. So we press enter, so then this character will actually be an enter character. We don't really want that. So what we can do there is we will just discard the error character by doing this. So the first character will be the one we actually type, and then when we hit enter, we're just going to throw that away. We're not assigning it to anything. And we're going to do that for each of them. Of course, this program is very fragile, but we're just using it to illustrate a point. So now compile that, and let's run the quiz. So the capital of the UK is London. The capital of France is Paris, and the capital of USA is Washington. And we got them all. Cool. Let's give that another go and just get 2 right. I'm going to get this one wrong. Capital of France is Paris. Capital of USA is Washington. 2 out of 3. And let's get only one of them right this time. One out of 3 needs improving. And then this time let's get them all wrong. So Paris, London, London. Terrible, 0 out of 3. So you can see our program works as we expected it to do. And you can see now the use of if statements in a kind of... And so there you can see the use of if statements in a program that might actually be useful for something rather than being abstract. You know, perhaps you could write some kind of quiz. Alright, that's all we're going to do for this week. Just a quick word about that getC function. The reason that we get the new line is because as an input stream it's only flushed and essentially made available to the program when we hit enter for that particular standard in input stream, which is what makes it useful for getting characters from the command line. Otherwise, as soon as you type a character, it will be available. Sometimes that behavior is desirable and you can get that behavior if you want it. Well, that's it for this week. You've learned all about branching. As an exercise, and this might be a bit tricky, try and write a quiz that takes a number in, a 2-digit number, so like 56, and compares it to an integer using getC. Now, I wonder if you can get the answer to this. It's a little bit tricky, but I'll give you a hint. You might have to look at the ASCII, man ASCII, and I'll show you the answers to that next week. But otherwise, I hope that was useful, and thanks for watching.